All right, so let's do another Kirchhoff's laws here. And in this one, I'm just going to show you how I solve these. Um, there are some tricks. Okay, so first thing I'm going to do is I'm just going to guess which way the currents are going. Let's guess something impossible, and I'll show you why. But sometimes that works pretty well. So I'm going to say that's I1 flows there, right? I'm just going to make every single current flow up the page. Okay, the battle of the currents, right? So I'm just going to guess. Okay, this may not make sense to you at all, but sometimes you just do this, right? So I'm just going to say I1, I2, and I3. They all flow up the page, right? And they all flow into this junction, right? So the junction rule for I1, I2, and I3 is that well, they all add up to 0. Okay, so I1 plus I2 plus I3 add up to 0. Now, of course, the only way that happens is that one or more of these is negative, right? So, in fact, they don't actually flow up the page. Some flow down the page, right? All right, but we'll just let the math tell us that, right? And the beauty of this is that I don't need to rearrange or do anything, right? So I'm done with that, right? Okay. So now let's do some loop rules. I'm going to pick this spot and just go clockwise over here, right? Now notice that these are all I1, right? So I got 5 and 6 and 13, right? 5, 6, and 13 adds up to 24. They're all going to be I1. They'll all combine eventually, right? So I can just say 24 I1, right? And I'm going downstream, so minus 24 I1. Okay, and then I go from negative to positive, so plus 24, right? Okay, and then this is 15. There's 8 and 7 I2, right? But they're going to be combined anyway, so I'm just going to say I'm going upstream, right? So plus 15 I2. And now I'm back, and that's 0, right? And the matrixable form of this is minus 24 I1 plus 15 I2 plus 0 I3, and then I got to put the 24 on the other side is negative 24. And there, that's matrixable, right? And now let's go do a loop on this side, right? I'm going to go whoop, 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 whoop. Okay, so I'm going downstream, so and I've got a 7 and an 8, but they're both I2, so I'll combine them right away. That's 15, so minus 15 I2. Okay, so here we go. It's going to be an 11 and a 10 I3, so that's 21 I3, right? But I'm going upstream, so plus 21 I3. Okay, and then I'm going this way, so I'm going from negative to positive through the 17, so plus 17, right? And I'm back. That's 0, right? And if I make this matrixable, it's no I1s, right? Minus 15 I2 plus 21 I3. And then let's put the 17 on the other side, so that equals negative 17. And now we can make a little matrix here, right? Our matrix is here. So I can represent this with this matrix. So 1, 1, 1, minus 24, 15, 0, and 0, negative 15, 21, and then that's to the minus 1, and then that's going to be, let's see, we've got 0, minus 24, minus 17, and that's going to be what I1, I2, I3 equals, right? Okay, so on my calculator, I'm going to go alpha zoom, go 3 by 3, and okay, and go 1, 1, 1, knowing full well that that one of those at least will be negative. So okay, so minus 24, okay, and 15, and then I'm going to go down here and go negative 15 and 21 plus 21. Yeah, there we go. All right, and then I'm going to go to invert that matrix, right? And then I'm going to go alpha zoom again. I'm going to go 3 by 1. Okay. And the answers are 0 and minus 24 and negative 17. Tumba. All right, there we go. Okay. Yeah, I got the right answers. Okay, so of course, the downside to this is that some of these things will be negative, but I've got 0.9491. I've got negative 0.80142. No, I'm sorry, 0.8142. And then the bottom one is negative 0.867. I'll say 77. Okay, that's what's down there. All right. I'm just afraid of writing there because it might come off the video frame, right? So really what's going on here is that the currents are, as one might have guessed, right? We guessed that that one would go up, and it really does go up, okay? So this current really does go like that, but because these last two were negative, right, this one actually goes this way, and this one goes this way. Okay, so the answers are 0.949 up. Okay, and because the other ones are negative, right? So 0.0814 down. The negatives just mean down, right? And negative 0.8677, right? So this guy is 0.9491 up. This is 0.08142 down, and this current here is negative. It's 0.8677 down. Okay, that's this guy. All right, so let's see. Through the 13, where's our 13? There it is. 13's got this guy, right? So the voltage on the 13 is IR is 0.9491 times 13. 0.9491 times 13. 12.3. And then the voltage on the 10 ohm is IR. And where's our 10? 10 is over here, so that's 0.8677 times 10, which is 8.68 volts, right? It's just 10 times that, right? Okay, so power, to find the power is I squared R. Right, so for the 8 ohm one, let's see, where's the 8? There it is right there. So it's 0.08142 squared. So this will be a small number times, that's the 8 ohm, right? Times 8. 0.08142 squared times 8. 0.0530 watts. All right, and then the power of the 6 ohm, right, is I squared R. And where's our 6? There it is. So it's going to be this current, right? 0.9491 squared times 6. 0.9491 squared times 6. And that's 5.40 watts. All right, now we want to do, let's see, pen color. Should we do black? I'll do black. Okay, now we want to figure out what the voltages are, right? Okay, this is the dreaded one, okay? Okay, so for this guy, I can either go this way, right? I want to go from here to here, right? And I can either go this way. Okay, so if I do that path, it's plus 24. Because I encounter that little 24 ohm, right? Then minus 13, because it really is flowing up, right? So minus IR, so minus 0.9491 times 13. I'm almost there. I've gone through this guy. And then remember, this guy really is going down, right? It really is going pointed, right? So I'm going to go downstream through the 8. So minus 0.08142. And all these things are current times resistance, right? And this guy is minus that because the current really goes down, right? And we know it really goes down because it was negative, and right? And it's times 8, right? So there we go. So let's just try this. 24 minus 0.9491 times 13. Oh, minus. Oh, look at that. Minus 0.08142 times 8. 11.01. All right, now let's go. I should be able to go this way too. I should be able to go whoop, whoop, which is the way, let's see. I guess it's the same number of circuit elements, so it really doesn't matter. But I should be able to go this way, so let's just do that, right? Okay, so I1, and we're going upstream, so plus 0.9491, and then it's a 5 plus 6, right? Okay, so that's upstream, and then upstream again through this guy, because it really is going down, right? So plus 0.08142 times 7, and then I'm there, right? Okay, so 0.9491 times 11. Okay, plus 0.08142 times 7. And I get 11.01. Alrighty. 11.0 volts is it. All right, so this is just fast and dirty. You know, if you want to, you can just say, look, all of the currents go up, okay? In this case, of course, I was wrong about 2 of the currents, right? I don't know if this is, you know, a helpful thing, but it's just a fast and simple way to do it, right? And then what I need to do is I need to go and I label which way the currents really go. This guy goes that way, that guy goes this way, this guy goes this way. I know that these 2 went down because I guessed up, but I got a negative number, okay? So I just label those guys in there and then just bust them out. The voltages are always IR, powers are always I squared R, and then the dreaded voltmeter one, right? You just have to go from one side to the other. I always go left to right, okay? And then if I do that, right, I should get, and then we're just basically, when we do that, right, we're using the same rules as for the loop law, only we don't make a full loop, we just go from here to here. All right, okay.